Centripetal acceleration and tangential velocity. Here we have one formula for centripetal acceleration. We've got two formulas for tangential velocity, that V with the subscript T. The formula used depends upon which variables you have available to you. The worksheet is intended for you to, the video is intended for you to check your answers. So please attempt the problems first. Pause the video as needed. Pause as needed. Attempt question 1, pause, and then check your answer. Okay. 2.5 meters per second. That's a velocity. 44 meters, that's a distance. Read the question. Athlete is running 2.5 meters per second around a circular track. Okay, so coach is standing in the middle. Athlete's out here running circular track. Distance between athlete and coach is 44 meters. Speed of athlete 2.5 meters per second. Because he's going in a circular motion, that is tangential velocity. And that is not a distance, it is in fact the radius of the circle. Question is asking for the centripetal acceleration, A subscript C. There's only one formula for that, right here. Tangential velocity squared divided by the radius. Plugging in the values, 2.5 squared divided by 44. Typing that into the calculator, 2.5 squared divided by 44. Calculator says 0.14204454, blah, blah, blah. Sig figs, 2 and 2, so just 2. Leading zero is not significant, so 0.14 meters per second squared because it's acceleration. There's your answer. That's his tangential velocity. Centripetal acceleration. Question number 2. Pause, attempt. All right, we have another athlete on the same circular track, so we still have that 44-meter radius. 1 minute, 45 seconds to complete 1 lap. So that's definitely time. We don't do minutes in physics, so that's 60 plus 45, 105 seconds. But this is different because it's the time to complete 1 lap. It doesn't say how many laps he went. This formula, new variable, uppercase T. This is what we call period. The time to do 1 cycle. In this case, a cycle happens to be a lap, something that's repeated. So you go round and around and around a track. Every lap, how much time does it take it to do? It's the period. So this is actually the period. Question is asking for tangential velocity. If I didn't give it away already, that's the formula we're going to use. Tangential velocity is 2 pi r over t. So typing that into the calculator, 2 pi is just a few buttons below down here to the left from the top. Pi, radius was 44, divided by period of 105. Calculator knows to multiply before we divide. Order of operations, 2.6329 is what the calculator gives us. Significant figures, we've got 3 in there number, 2 in that number, so just 2 sig figs, 2.6. Solving for velocity, meters per second. All right, so that's our tangential velocity for athlete number 2. Question number 3, explain which athlete is faster. Athlete from question number 1 here, or athlete from question number 2 here. So, faster. Again, pause, attempt before you check your answer. Faster is referring to velocity. So, number 1, velocity was 2.5 meters per second. That's letting us know it's velocity. So velocity is 2.5, not the acceleration. That's something different. A number 2, that's the velocity of epoch number 2, 2.6 meters per second. Comparing velocities, 2.6 is definitely greater than 2.5. So athlete number 2 is faster. Pay attention to what your variables are, what you're actually measuring. Number 4, the radius of the Earth is 637. Okay, so picture the Earth, cut it in half from the center to the crust, from the center of the core to the edge of the crust. That right there, 637,100 meters from the center to the surface. Now, it takes 24 hours to travel, and the question's written incorrectly, to travel the circumference. So you, on the surface, the Earth spins in 24 hours. You're back to here 24 hours later. Now, we talked about some relative velocity. Even though you're sitting still, you're actually on a moving surface of a planet. So how fast is that moving surface moving? How fast are you moving on that surface of the planet? So, it takes 24 hours. Conveniently, that was converted into seconds for you. What is your average tangential velocity in meters per second? Dun, dun, dun. So, here we go. Again, attempt this first and then check your answer with the video. Pause the video. So, that time is actually period because that's the amount of time it takes to do the complete cycle. Tangential velocity is the question. So, tangential velocity, formula 2 pi r over the period. Typing that into the calculator. That's what it looks like in your calculator. Calculator says 46.33121.9. Sig figs, 4, 3, so 3, 46.3 velocity meters per second. Now I know that number doesn't have much meaning for you, but just as an interesting little fact, that's 103 miles per hour. That's how fast you're moving right now. All the time, you're moving 103 miles per hour. Pretty cool. Obviously, if you're on the equator, if you're a little bit higher up, which we are, it's a little bit less, but hey, it's like 100 miles per hour. That's pretty awesome. What is your centripetal acceleration due to your position on the surface of Earth? So the Earth is spinning really, really fast, okay? But we're not flying off of it. Interesting. So why? Pause. Calculate. Then check your answer. All this information is asking for the centripetal acceleration. Well, the formula for centripetal acceleration, we need the tangential velocity squared divided by the radius. Well, we just solved the tangential velocity up here. So we're going to use the number we solved for. 46.3 meters per second is the tangential velocity. And the radius, which was also given up there, 637,100 meters, both information from question number 4, that's the radius. Centripetal acceleration is the tangential velocity squared divided by the radius. So 46.3 squared divided by 637,100. And the calculator says 0.00336476. It's a small number. It's a very small number. Considering the size of our planet, it's a small number. It's the size of the radius is so big. That's why even though you're going 100 miles per hour and you square that, the radius is so big that it's a pretty small number. The centripetal acceleration is quite small. So, this is a number worth writing into scientific notation. Three significant figures. 3.36 times 10 to the 1, 2, 3, negative 3. Acceleration, meters per second squared. All right, question number 6. Why don't you feel the centripetal acceleration due to the rotation of Earth? Okay, so why don't you feel it? So considering all the forces acting on you, why don't you feel it? Pause. So all the forces acting on you. If you're just standing there, minding your own business on the surface of Earth, you have this pull that's pulling you inward. That pulling you inward is gravity of 9.81 meters per second squared. But the Earth is simultaneously spinning, and that spinning motion is causing a centripetal acceleration that wants to fling you off the surface, and that centripetal acceleration is 0.00336. It's a very small number compared to the gigantic gravity of 9.81. Okay, so the acceleration of gravity is much stronger or bigger than the centripetal acceleration due to the Earth's rotation. Okay. On this playlist, you will see, or hopefully you saw, an amusement park ride that plays on this idea of centripetal acceleration. The small round room, everyone stands against the wall. The room is actually spun super, super fast. And that centripetal acceleration exceeds the acceleration due to gravity that's pulling you down. It pushes you against the wall, and then the floor of the room drops out. The people remain stuck to the wall and they don't fall. So let's do the calculations. Let's assume the room has a diameter of 4 meters. What is the tangential velocity necessary to achieve a centripetal acceleration of 11 meters per second squared? I chose 11 because it's greater than gravity of 9.81. Okay, we just need it to be more, notably more. Go ahead, calculate, pause. Okay, so we have 4.0 meters. That's the diameter. Dun, dun, dun. We need radius. So 2.0, well, that's the diameter. 2.0 meters would be radius. Okay, we have 11 meters per second squared. All right, that's the centripetal acceleration. So the question is the tangential velocity necessary to achieve that. Well, looking at our formulas, tangential velocity, square root of the radius, acceleration, centripetal acceleration, voila. That's the formula we want. So, tangential velocity is equal to the square root of the radius multiplied by the centripetal acceleration. Radius 2.0 multiplied by the centripetal acceleration, 11. So 2 times 11, 22. we need the square root of 22. So if you can't remember where you find it on your calculator, square root, okay? You see it right here above the square button next to 7. So second square, so we get the square root of 22, 4.69. Significant figures, just 2. So 4.7 tangential velocity is in meters per second. So that's going to be spinning at 4.7 meters per second in order for this to work. There you go.